Okay, the pH scale. This is a big part of biology. You do have an exercise is based on this. So I wanted to go through this individually. Here shows a beaker full of a solution. This is hydrochloric acid. And the idea here is when you pour hydrochloric acid, you can tell when it's joined together. Hydrochloric acid is called a molecule or compound. It's got hydrogen and chloride in it. But you see there's no pluses and minuses. When they're bound together to form a molecule, they lose the positive negative properties. When you put hydrochloric acid into a solution, you get hydrogen ions and you get chloride ions. So here's the negatives. A negative is called an anion. A positive is called a cation with a C, but they're all ions or electrolytes. So, first rule of thumb, you guys have to know what is an acid. An acid is something that when it's released into a solution like this, water or another kind of solvent, that it breaks apart or disassociates into an acid or acids. Hydrochloric acid, very strong, pH of about 1, breaks into hydrogen ions and chloride ions. So that the fact that it releases these makes it an acid. There are acids that are very strong, which means they completely disassociate, and there are acids that are weaker that do not disassociate that much. This is called a base. A substance that releases, these are called hydroxide or hydroxyl ions. These OH negatives, that by definition is a base. Or you could say a substance that releases ions that combine with acids. Remember, negatives and positives are attracted to each other. So anyway, so we'll get to that in a minute. But so in first case first, this is what makes something a base. The fact that it releases these hydroxide ions, OH negative, makes that substance a base. This is sodium hydroxide. There's the sodium ion. There's the hydroxide ion. So bound together, it's sodium hydroxide. Sodium binds with a lot of things because remember it has an atomic number of 11. It's always wanting to bind with other things. It's always wanting to lose that outer electron so that it can become more stable. All right, on a pH scale, it goes from 0 to 14. Below 7 is considered acidic. The lower the number, the more acidic. 7's neutral, which is water. And above 7 is more basic or more alkaline. Now, I can make this a little bigger. And I can move. I was hoping I could. There we go. And move it up a little bit. All right, there we go. So it says here blood pH is 7.35 to 7.45. Blood pH is normally a little bit basic. So why is this important? Acidity causes bonds that hold the bonding within atoms to break apart. So does extreme alkalinity or more basic. That would cause metabolic issues. And every organism is adapted to a different pH. This one doesn't have it. There are bacteria that can exist on this end of the scale. Human beings, for the most part, it says blood right there. We do have organs like a stomach, kidneys that are slightly acidic. Well, stomach's very acidic, but yeah, we exist within this range. Most life exists between 3 and 9 right here. You do have the extremes. There are bacteria called acidophiles that can live in stomach acid. If you've ever heard of H. pylori, Helicobacter pylori causes stomach ulcers. They can buffer the acid. Where I was going earlier was if you release these OH negatives and hydrogen ions together, they bind together to form water, H2O, and water is neutral. So, real life example, let's say you go to Buffalo Wild Wings and you eat their super hot wings and your stomach is killing you. You come home, you see the, don't be drinking these things. On most pH scales around there, Alka-Seltzer, milk of magnesia, I believe is a 9. Things that make your stomach take away stomach pain. If you drink something like Alka-Seltzer or milk of magnesia, you're pouring a bunch of these hydroxide ions into your stomach. And what ends up happening is they combine with these hydrogen ions, and now you have buffered your stomach acid, which creates water. So you've reduced the pH. You've actually taken it from a low number and you've raised it back up to where it's not causing any pain. All right, but the main reason you want to be careful with acidity, or even on this end alkalinity, is it causes bonds to break up within atoms or elements, which in human beings' case, you're going to start having metabolic issues. You can't have bonding, the enzymes, the proteins that keep your body functioning, they will start to, the term is they will denature. They'll start changing shape. Here is that guy there. There's water, then we got some ice. Okay, there's a pH scale. Not quite there yet. And then I have another pH scale here. Let me see if I can make this a little bit bigger. So some more terms. pH 7, equal concentrations. Less than 7, acidic. Greater than 7 is more basic. I know this writing is very small, but you can see that says egg white. There's milk of magnesia, 10.5. Say don't drink ammonia. That wouldn't be good for you. But yeah, it says alkalosis occurs at higher pHs. That's too basic. Acidosis, person might not be breathing enough, or kidney issue, goes below 7. And so that's fatal for human beings. All right. Well, I know that was short. I have one more video for you, and I'm going to cover the macromolecules. But yeah, the pH scale is very important, and it will cause metabolic issues, too acidic, too basic, and it does cause the bonding of molecules to start breaking up. All right, so that's the pH scale.